Hello, everyone. My name is Mingming Fan, and I'm assistant professor at the Hong Kong University of Science and Technology in Guangzhou. Today, I'm going to present a research on human-AI collaboration for UX evaluation, effects of explanations, and synchronization. This work was done with my co-authors, Xianyou, Jian, Denise Yu, Vera, Liao, and Jian, Zhao. Usability testing with Think-Aloud protocols is widely used in industry to detect usability problems. During the test, participants will work on the tasks while at the same time verbalizing their thought processes. And during the analysis, evaluators will watch the recordings to analyze the Think-Aloud verbalizations among other behaviors to identify usability problems. However, manually analyzing usability test videos is arduous. Reviewing these video recordings is time-consuming, and the evaluators may face the evaluator effect, which means that they may miss certain UX problems due to their personal biases. Therefore, the UX evaluators are encouraged to collaborate with each other. However, in practice, they often analyze test sessions alone. Very few had a chance to gain a different perspective from the co-workers. In light of the advancement of AI, researchers have investigated human-AI collaboration to improve the UX evaluation analysis efficiency. One representative work of this line of research is called VisTA. So VisTA is a visual analytical tool that visualizes an AI's predicted usability problems as a sequence of spikes on a timeline. It also visualizes the AI's input features as the explanations of its behavior to the evaluator. Prior studies have suggested that the human-AI collaboration allows the evaluators to identify more UX problems than they work alone. However, the prior human-AI collaborative tools suffer an important limitation. For example, such tools often show the AI's predictions all at once, upfront, before the evaluators even start their own analyses. So this might bias their analysis. This type of collaboration between the AI and the evaluator is asynchronous. Moreover, evaluators wanted to know more about how the AI makes decisions in addition to seeing its input features. To improve the human-AI collaboration, we draw inspirations from human-human collaboration, which has two dimensions. The first dimension is called work context, which means how do evaluators collaborate. So in addition to asynchronous collaboration, there's also asynchronous collaboration. The other dimension is agency, which means how much do users feel they're in control. The agency can be moderated by the amount of explanations provided to them. So in order to investigate the work context, in addition to asynchronous collaboration as investigated in prior studies, we also proposed a new design for synchronous collaboration, in which the AI shows its predictions progressively to the point where the video is being played. We also revised the explanations to provide more information that the evaluators wanted from prior studies. For example, we included the UX design guideline that is violated, and we reorganized the input features as a set of icons and a scannable text to facilitate the consumption of such information. With these new designs, we investigated two research questions. The first one is how would synchronization of AI and evaluator affect evaluators' performance and experience in their analysis? The second one is how would explanations of AI affect the evaluators' performance and experiences in their analysis? To answer research questions, we designed experimental design with 4 conditions. Next, I'm going to explain these 4 conditions. So asynchronous AI without explanation is similar to some of the prior studies design in a sense that the AI presents all its predictions at the very beginning of the analysis, so that when the evaluator starts the analysis, they already see all the AI's predictions. Asynchronous AI with explanation is similar to prior interface, except that it also shows the AI's explanations of this behavior. Synchronous AI without explanation, on the other hand, reviews the AI's predictions progressively as the video is being played. Here is a short video demo. As you can see that as the video is being played, the AI's predictions is reviewed to the evaluator progressively. So synchronous AI with explanation is similar to prior interface, except that it also shows the AI's explanations. So with these 4 designs, we conducted a 2x2 mixed design study. With these 2 factors, we recruited 24 UX evaluators with various prior UX experience to work on tasks which they identified UX problems of 2 test videos using these 4 interfaces. We performed the mixed effects regression model on quantitative data, such as the number of UX problems evaluators identified, the number of video jump forwards and rewinds, including also the subject ratings. We performed thematic analysis of qualitative data, such as interview data. Due to time limit, I only highlight some of the key findings here. So this figure shows the number of UX problems the evaluators identified. Here is the asynchronous AI without explanation. As you can see that with synchronization, evaluators identified significantly more problems. Similarly, with explanation, evaluators also identified more problems. We evaluated the engagement in the analysis by looking at evaluators' video playing behaviors, such as how many times they forwarded, jumped the video, or they rewinded the video, which were shown in these 2 figures. As you can see that with synchronization, evaluators jump forwarded and rewinded the videos more often, which means they engaged in analysis more. And similarly with explanation, evaluators also engaged in the analysis more. So with synchronous AI, participants felt that as if they were working with a co-worker at the same time. With explanations, participants felt that they understood how the AI works better. So the key takeaway is that both synchronous AI and AI with explanations could improve evaluators' productivity of and engagement in their analyses. So for future research directions, one is interesting direction is to look at other synchronous collaboration modes, for example, on-demand and synchronous collaboration, in which AI reviews its decisions and rationales upon request. It will be also interesting to look at human AI collaboration for identifying common usability problems across multiple usability test videos. With that, I'll conclude my talk, and I'd like to take any questions. Thank you for watching.